This is the problem set for annuities, which is on page 4 of the compound interest problem set. So number 1, Sarah Jane started saving her pension. She put 1,500 UK pounds into an annuity each year. Given that the annuity pays 3.5% interest, calculate how much she will have saved after 30 years and compare that to the total amount invested. Okay, so as with all annuity problems, you'll be using the Finance TVM Solver app. Okay, and so let's identify some of the elements that we're going to use in the problem here. So let's see. So we're going to put in 1,500 pounds each year. The annuity pays 3.5% interest, and it doesn't say if that's per year or per month, but we assume then it's per year. How much will she have saved after 30 years? And compare that to the total amount invested. Okay, one of the tricky things about annuity problems relative to compound interest problems is in compound interest, N is always number of years. And in annuity problems, N is usually number of months, unless the problem only works in years. So if there's any part of the problem which mentions months, then N becomes months. And if it only talks about years, then we can still consider it to be years. So in this particular case, do they ever talk about months? No, they only talk about the fact that it's 30 years of investing, and that she pays 1,500 pounds each year. So everything is annual. So in this case, N will be annual. And so we can use 30 for N. And then, so 3.5% would be the annual interest because everything is in years here. And then 1,500 would be our PMT, or payment. So let's input that data in here. So the N value is going to be 30, and the I value is going to be 3.5. Oops, 3.5. 3.5. And the present value, well, how much does it start with? It starts out with 0, so the present value is 0. The payment is 1,500 per year. And the FV, how much will she have saved after 30 years? The future value is what we're trying to calculate, so we don't need to fill in anything there. The payments per year and the compoundings per year is 1 each because in all of our annuities problem, we're always going to put 1 for each of those, okay? And then we're just going to press Alt Alpha Enter on the FV to find out the total amount she saved. So the total amount she saved is 77,434.02 pounds. And so when you look at this value, 77,434.02, this corresponds to how much she has invested plus all the interest after 30 years. So she put in 1,500 per month every month, or I'm sorry, 1,500 per year every year for 30 years. You would expect to have around 30 times 1,500, which is about 45,000 pounds, and you actually have much more because of the interest. Okay, compare that to the total amount of invested. So if you want to find out how much exactly did she put in, it's simply 1,500 times 30, which you do without the finance app because you're not calculating with interest, and you find out that it's 45,000. So that's quite a bit more, isn't it? If you subtract the two, that'll give you the amount of interest, and that would be about 32,000 in interest, right? Okay, let's go to the next one. Okay, for this next problem, Pedro puts 2,500 Mexican pesos into an annuity that pays 2.8% interest per annum every month for 5 years. Calculate how much he has saved at the end of the 5 years. So, looks like the N might be 5 years, except for the fact that, look, it says every month for 5 years. So actually the N value in this case has to be the number of months, and then the interest rate needs to also be calculated per month. So this is a little bit tricky. Remember how I said that in annuity problems, if you are paying or getting paid every month, then everything needs to be expressed in months. So the 2.8% becomes 2.8% divided by 12 months for the monthly interest rate. And then for every month for 5 years, that becomes 5 times 12 to become 60 months. Okay? And so, and of course this would be PMT, the 2,500. So let's put that in now. So we're going to put into TVM solver, we're going to put 5 times 12 months, which would be 60. You can actually write 5 times 12 here. That actually works. And interest is going to be 2.8 divided by 12. And the present value is going to be how much the annuity is worth today, which is 0. And then he is going to put in 2,500 per month. Okay, and then remember that in annuity problems, P over Y and C over Y are always 1. Now I'm going to do alpha solve on top of FB, and then I found out the future value, or the value of what he has saved at the end of the 5 years, is going to be 160,806.67. And remember, if it's a finance amount, we always want to figure out the cents. Okay, number 3. Stygian has been left an annuity of 25,000 euros in a will. The annuity is for 10 years at 6% per annum paid out annually. Work out the amount that he receives each year. Okay, so since this is not per month, it's per year, we can consider that N is actually going to be the 10 years. We don't need to multiply by 12. The 6% can be considered directly I. We don't have to divide by 12. And the annuity's value is $25,000, but it's going to be broken up into monthly payments. So we can consider that to be the present value. And what would be the future value? Well, what's going to happen is there's going to start out to be $25,000 in the account. Every month they're going to pay you a little bit. It is over when the balance reaches 0. So the future value we're looking at is actually 0. We already know that the future value is 0. The question is, how much is going to be paid out each year for it to exactly finish the money in 10 years? So let's do that. So the 10 years, remember, is N. And we're actually using years here because the payments are in years and not in month. The interest is going to be 6% because it's 6% per year. We don't have to divide that per month again. The present value is the initial amount, or the amount today, which is 25,000. And the payment amount is unknown, and the future value is exactly 0 because we want it to exactly finish up the money. Remember, P over Y and C over Y is always going to be 1. And the answer is, every month we're going to get 3396.70, and this is euros, right? By the way, we should always put the currency for the amounts when the answer is an amount, right? So, okay. All right, number 4. Fiona has won an annuity of $6,000. It is for 5 years at 4.8% per annum to be paid out monthly. Okay, since it's being paid out monthly, we need to convert the number of time periods from years to months, and we need to convert the interest rate, which is per year, into per month too. So in that case, the 4.8 becomes 4.8 divided by 12, so that it's a monthly interest rate. And then the number of years, which is 5, needs to be multiplied times 12 because that is the number of periods that we are having the annuity over, okay? So you can actually type in 5 times 12 for n, and it actually calculates the 60 there. The interest is going to be 4.8 divided by 12, not 4.8. And then the present value is going to be $6,000 because that's what we start with in the account. And then the payment amount is, we don't know yet. And the future value is 0 because we want to pay everything out every month, okay? And then we just want to know, okay, and remember P over Y and C over Y is 1 as usual. So we just do alpha solve on top of the payment amount to see what payment can be made every month to make that last exactly 5 years. And the answer is $112.68. Number 5, Mikey wants to receive an annuity of 500 pounds a month for 5 years. The monthly interest rate is 0.8%. Determine the present value of the annuity. Okay, this is kind of backwards. Usually we start with the present value, we calculate the future value or maybe the payment. In this case, we're calculating the present value. So the annuity is paid once a month, so we're going to do everything in months. They're nice about it. They give us the monthly interest rate of 0.8%, so we don't need to divide the annual interest rate by 12 because it's already monthly, okay? And the payment amount is $500, and it's 5 years, but remember we're doing it in a monthly problem, so it's 5 times 12 equals 60, so it's actually 60 would be the end value. Okay, we already have 60 there. And then we're going to put in an I value of 0.8 because we know that the monthly interest rate of 0.8. If you want to know what that is annually, you would multiply it times 12, but we don't need to because actually this problem is being done totally monthly. The present value is what we're looking for, so we can just leave whatever we're going to have there, and we're just going to press alpha solve on top of that when we're all done. And then the amount that we are going to pay out of the account is 500 pounds a month. So we put negative 500 here because we're paying out, so negative 500. And then FV we want to be 0 because we want to exactly finish up all the money in the account at the end of the annuity. And then P over Y and C over Y would be 1 each. And then let's go to P over PV, and then let's press alpha solve on it. You notice we get a positive 23,752. That makes sense for it to be positive because at the initially they put $23,000 in the account. We take out $500 a month, and then eventually it'll hit future value of 0, right? So the present value of the annuity is going to be 23,752.11, and that is in pounds, right? Okay. Last problem on the page. You have $20,000 US and want to get a monthly income for 10 years. If the monthly interest rate is 0.9%, find how much you would receive each month. Comment on why you think that you would do this. Okay, so this is a monthly problem or a yearly problem. Well, it's a monthly income, so it is a monthly problem, which means that the 10 years you need to multiply times 12 to get the end value. The end value is going to be 120 instead of just 10. The monthly interest rate, they were kind enough to already give it divided by month, so it's 0.9%. You don't need to divide it by 12. And they want to know how much you would receive each month, which is PMT, right? The $20,000 is the present value because that's how much you have right now, and you want to know how the $20,000, if it was going to be a monthly income stream, how much would you receive? And so first we put in that it's going to be 120 months total. N equals 120. The interest rate is 0.9, and the present value is 20,000. And the FV is going to be 0 because you want it to exactly finish up the $20,000. And the P over Y and the C over Y is going to be 1 as usual. So we do alpha solve, and it turns out that it's going to be $273.24 a month. And then it says, why do you think you would do this? And so why would you take your $20,000, give it to an annuities company, and then say, okay, instead of me having this $20,000 in my pocket, how about if you pay me $273.24 a month instead for 10 years? And maybe it's because you're guaranteeing an interest rate that is 0.9% a month, which is actually quite good for, especially for the US. If you multiply 0.9 times 12, that would give you like 8.4% a year. And normally to get 8.4% return on investment in the US, you would need to put that money in stocks. But if you put it in stocks, then it wouldn't be a guaranteed 8.4%. You might get more, you might get less, you might even get negative. So in order to, if you actually made an arrangement with an annuities company that would pay you 8.4% per year guaranteed, that is worth something, because they're basically giving you a better interest rate than you would just putting it in the bank, and it's an interest rate that's as good as putting it in stocks, but they're guaranteeing you the rate. Okay, so this is a really good deal. That's probably why you would do it, so that you would have a guaranteed, steady income flow, which a lot of people want when they're going to retire.